Here with our period 8 class, going over chapter 9, this example from quiz C. All right, so hopefully taking a moment to read this question, all right, to make sure we know what's going on. So we have baseball coaches using a radar gun to measure the speed of a pitcher's fastball. They record the outcomes such as hits and strikeouts. This scatter plot here shows the relationship between the average speed of a fastball and the average number of strikeouts per 9 innings for each pitcher on the Bulldogs. Go Bulldogs. Based on the past season. All right? So let's do number 1. I'm going to just skip that first question and just do describe the association. All right? So what do I need to be thinking when I answer this question? I'm going to go direction, form, and strength. But the order doesn't matter. All right? So let's go with Ezekiel. How would you describe the association from this scatter plot?
Non-linear, positive, strong.
Okay, so you're going to go with there is a not linear, positive, strong association. Don't forget the context, Ezekiel, right? Between speed and strikeouts. Does anyone disagree? Do you disagree? Well, you agree with that?
Like it's kind of
I know, it's kind of linear, but there's something that even if you disagree, that like maybe you think this could be linear. I do think I kind of agree with you. There's a curve there, or we'll talk next week on Monday and Wednesday about what we can do about that. But really, I also want to make sure you mention possible outlier, right? Because this picture right here, this picture right here has a pretty almost, is it the slowest? Tied with the slowest average fastball, it looks like, right, on the team in terms of the pitching staff, right? But almost the highest number of strikeouts per 9 innings. So something interesting is going on there. So I'm going to answer this in number 2. Say that there is a pitcher that has the slowest average fastball. I'm going to make sure you know I'm talking about the speed, but is almost the highest strikeouts per 9 innings. Yes, Ezekiel, sorry.
So we were to get a question like that, we'd have to like detail.
So if you remember from the first test, and we had that question about Corporation A and Corporation B about which one you'd rather work for, all right? And one of the things that they graded on the AP graders was you had to comment on the outliers. So this is one of those things where when you're describing the association, you really need to mention that this could be something interesting going on, a possible outlier. All right, so just keep that in mind when you're doing the AP questions. Yes. Yeah, that would be more like this is shh. Well, guys, this is really an extension of this one, right? I think what your brain is thinking, it should go here. That's what you're asking, right? Yeah. Now, we kind of skip this. Is there a pattern generally? What is the general pattern when it comes to the speed of a pitcher's average fastball and the number of strikeouts per 9 innings? That makes sense. And if you don't know anything about baseball, that's fine. But if you've watched some baseball, right, really that the faster the average fastball, the higher the Ks per 9 innings. K means strikeout. And remember, use those weasel words, right? This is in general, right? That's the general consensus. Are there pitchers out there who do not have a fast average fastball but are still getting a high number of strikeouts per 9 innings? Yes, this picture right here is an example. We've commented on this picture. Any ideas as to what is going on?
He plays against the bad.
Okay, interesting. So he's on the same team. So you're saying every time his turn comes up, he's pitching against the weaker hitters?
Yeah.
Okay, interesting. I don't necessarily disagree like from time to time. That could be true, Eric, but this is over, if you remember the problem. It says on the entire season. So I don't know what league this is, but talking about an entire season, probably hard for that to really hold up, right? Over time, they're going to end up facing like some good hitters, some bad hitters. But interesting thought, good thought. Any other thoughts? Ooh, somebody said something. What? Somebody said left-handed? Who said left-handed? David, you said left. Why did you say left-handed? Okay, so the hitters might be used to more seeing right-handed pitchers, so somebody throws lefty, even though they throw slow, right? On the average fastball, they're still getting a lot of strikeouts. Interesting. Did you say something, Ricardo? He curves the ball. So he throws a curveball. I'm going to latch onto your idea for a second. I think it's more of what Ricardo's saying, or I think it's something about a special pitch this pitcher throws. And I don't think it's a curveball because most pitchers throw a curveball. Most pitchers throw a four-seam fastball. Most pitchers throw a sinker or have some kind of sink. There's a particular pitch I'm thinking of, not a slider. A lot of pitchers throw a slider. A particular pitch that many, almost all pitchers do not have. Their knuckleball is exactly right, Eric. All right, so I think, I'm going to put this to the side. I think, I'm going to show you, I'll show you a video from YouTube in a moment. I think this pitcher throws a knuckleball. So the reason it's called this, Ernesto, is because you hold it like this, and then you don't actually snap your wrist like you would do for a fastball or curveball. You actually like kind of like toss it like this, and so it floats. It doesn't spin. It's you know, like when a soccer player kicks the ball and the ball is like not spinning and it knuckles, it floats, and the goalkeeper has trouble. It's the same idea for a baseball. You be doing that? We're gonna work on that English though. All right, let's do number 3. That was Alonzo for those keeping track at home. Number 3. Shh. I'm going back. Guys, I want to make it very clear. Listen, shh. This is important. Do you need to do this on the AP exam? No, this is just me thinking, right, what could be causing this? On the AP exam, Ezekiel's brain is right. You just need to comment that there's something unusual, a possible outlier going on with that pitcher. Okay? So it's not necessarily something you have to do to get full credit. I'm just curious as your thoughts. You guys had some great thoughts about what could be happening with that pitcher. Okay? All right, let's keep going. Number 3. Now, this is from if you watch my lecture or not, or if you started to read chapter 9. It's a short chapter. If you read or watched my lecture, you might actually know the answer to this. If you did not, then you will not know the answer. Do you think the association would be stronger or weaker if we use data from 1 month of the season? So let me just explain what you need to know from the chapter. All right. If you're going to be dealing in averages, I'm going to repeat this many times. If you're going to be dealing with averages, then your association will appear stronger than it actually is. I'll repeat that. If you're going to deal with averages, right? If you're going to deal with averages, your association will appear stronger than it actually is. So in this case, are we dealing with averages on this scatter plot? We are dealing with averages, right? Based on the entire season, average fastball, average Ks per 9 inning. So this right here, if we had the individual data, right? Every single outing, what their average fastball was and how many Ks they got, you would see obviously a lot more dots, right? Because every pitcher would have many more dots, all right? And you would see more scatter, all right? Have more variation. So to answer this question, it would be weaker because the scatter plot would show more variation. All right, so really what you need to think is there'd be more dots and there'd be more spread out, there would be more scatter. And the more spread out they are, the weaker that relationship is. Okay? That's good with that? So make sure what you're taking with you from this is that if you read that a scatter plot is dealing with averages, you're like, whoa, hold on. That's going to be stronger than it actually is. Okay? Say it again. Okay. Ooh, that was another good one. Maybe the pitcher throws like underhand or submarine. Yeah, that's a very good thought. You know what? I'm going to add that. Can I add that? All right. Or Joshua thought maybe they throw using a unique style. I'll say example submarine. The guy using the sticky stuff? All right, let's do the last one, then we'll be done. Good thought, Joshua. That's a really good thought. All right, number 4. Do you think a model based on these data could accurately predict the average number of strikeouts for a pitcher with an average fastball speed of 70 miles per hour? So like me, right? Imagine I walk up there, so I can throw 70, all right? And I'm on the team now, right? Do you think before I start my first outing, do you think that this model could predict what my Ks per 9 inning should be? Do you think this could? Why not?
It's all about technique.
Everyone's different, bro.
There is a statistical answer besides your answers, besides no reason. Interesting. What's the lowest average? Well, I guess not 82. What's the lowest on the team right now? 84. 84 is my 70-mile-an-hour fastball going to be within this range of 84 to 96? No. So this term that you've seen before, hope you remember from chapter 8, is called extrapolation. All right? Really don't do it. All right? Now, what most students think, and I'm going to write more than this, what most students think is that when I use the word extrapolation, is that I'm talking about going further to the right, like a person who throws 100 miles per hour. But it's also about going outside the range to the left or below it, okay? So don't just think that we're talking about like going into the future or something further down the road. It can also be like backing up as well. So 70 miles an hour is not in the range of, I think it was 84 to 94. Is it 94? 96, I'm sorry. 96, my bad, man. 96 miles per hour for the fastball. So this is extrapolation, all right? And you really shouldn't do it. I'm not saying you couldn't, right? But you're going to just get yourself into trouble if you start trying to do that, all right? So I had a conversation a little bit with Anthony about this. I think it was last week, Anthony. I could be wrong. We were talking about like gas prices, right? When people try to predict the price of gasoline, right, you've noticed even just in the last 6 months, been a lot of change. So trying to predict in the future is called extrapolation, and it's very difficult to do. If you're something who is actually good at that, using your own modeling techniques to figure out and you hit right on the money, you could make a lot of money doing that for your job. Okay? It's very challenging to do. All right? So just be aware when you're trying to do extrapolation.